The great thing about CNC is its scalability. CNCs vary from desktop-size engraving tools to industrial machines for production. Here I'm going to be taking a look at larger CNC routers, often found in makerspaces, workshops, and even on construction sites. Most places require you to take a training course before using the CNC, for safety and to learn how to set up the machine. Getting the right feeds and speeds for your CNC setup and choosing the right bits can be tricky, especially since every machine is different. So make sure to communicate with the fabricator of your design the intended tolerances and finish quality. When it comes to designing a product to be CNC'd, there's one aspect that's the cause of a great deal of consideration: kerf. Kerf simply means the thickness of the machine bit that's cutting the material. So if you cut along a straight line with a 6mm bit, you will in fact cut away 3mm either side of the line. This effect has interesting consequences for the design, such as dog bones. Dog bones are required when cutting the inside corners of slots, because it's almost impossible to cut out a perfect internal right angle with a CNC. There are a couple of variations of the dog bone, which are useful depending on if you want clearance, tight, or interference fits. If you use Fusion 360, there's a great plugin available on GitHub that adds a dog bone feature to your designs quickly. The link will be available in the supporting material. CNCs have the capability of carving out complex 3D geometry to a certain extent. If you're designing a product that has curved surfaces, you have to consider that any overhangs or undercuts might require a CNC with more axes, like a 5-axis CNC. And if you require a high-quality surface finish, such as a smoothing cut after a roughing cut, then your fabrication process might require a tool change. These sophisticated machines and complicated tool changes are very costly and time-consuming, which dramatically diminishes how distributive your design can be. So if possible, try to constrict your CNC operations to profiles, pockets, drilling, and roughing cuts that do not require tool changes or additional axes. Lastly, I want to talk about file sharing. With designs intended for 3D printing, STLs are the most common. With designs intended for laser cutting, you need vectors like SVGs or 2D drawing files like DXFs. But when setting up for CNC, there's a real mix between 2D and 3D. Preparing your toolpaths in a program like VCarve is typically done with a 2D drawing, but preparing a toolpath in Fusion 60 is done with a solid 3D model. I would recommend, when sharing your design for CNC, that you prepare it in both DXF and STEP, so that the fabricator can choose what's best for them, unless already specified. CNCs are one of my favorite digital fabrication methods, and are a crucial component to distributed design being a viable alternative to mass production, as well as enabling distributed design to scale up into large furniture, architecture, urban design, and more.